Hello, my name is Chintan Rajpara and I am leading Cloud and Infra team at videosdk.live. In this video, I will be talking about interactive live streaming and also we will be creating an interactive live streaming application. So let's understand what is interactive live streaming. But before that, we need to understand what is standard live streaming. So, standard live streaming, which is also called as traditional live streaming, is a way to broadcast the video and audio streams to thousands of participants, but in some cases, it's even millions of participants who are actively watching the streams. But in standard live stream, the audience are not able to interact with their speakers. Let's take an example. In a stream, if a speaker wants to take a poll from their audience, so there is no way for that. There is no two-way communication between the audience and the speakers. Yes, there is chat, but there is not a two-way simultaneous communication. So the interaction and the engagement between speakers and the audience are limited in the standard live stream. Hence, in that place, interactive live streaming comes into the picture. Interactive live streaming not only offers the live streaming, but also it allows speaker to engage with their audience in various platforms, platform to platform, or we can say application to application. The need of interaction varies accordingly, but there are endless possibilities of interaction. But if it is so cool, then can we integrate interactive live streaming into our application? Now, to answer this question, let's understand the complexity behind it. So, to successfully host an interactive live streaming platform into any application, a robust infrastructure is essential to handle the workload of serving thousands of participants while maintaining the stability, reliability, and optimization. However, building this type of highly complex application is indeed possible. In fact, Video SDK already provides a well-tested infrastructure that can handle this kind of workload. Therefore, we will be creating an interactive live streaming app using videosdk.live, which will ensure the reliability and stability of the platform to serve all our users. So let's get started. So I will be creating a React web application for interactive live streaming. For that I will use Video SDK's React library, Video SDK's HLS composition, Video SDK's HLS streaming. So for our application there will be two types of users. First speaker and second viewer. Speaker will have all media controls, that is they can toggle their webcam, microphone, and also they can share their screen to the audience. Speaker can also start HLS stream so that viewers can watch the HLS streams. Now viewer will not have any media controls, they will not able to turn on or turn off their webcam. By default everything will be turned off. They will watch a Video SDK HLS stream once the speaker starts an HLS stream. Now let's create our application by using a create React app. So our application was initialized by create React app. Now we will install some dependencies such as React SDK, React Player, and HLS.js. Let's discuss about the project structure. There will be three screens. First one will be welcome screen, second speaker screen, and third will be viewer screen. The welcome screen will be responsible to generate a new meeting, or it will be responsible as a join screen. Now the speaker screen will be useful for speakers, and in that screen the speaker can toggle the microphone, webcam, and also they can toggle the HLS streams. In viewer screen we will just show or display the HLS stream that was started by speaker. Now to host all of the screens we will require app.js file to conditionally render those screens. So I will replace this code which was default created by create React app, and I will replace this code with this code, and this will conditionally render a speaker screen, viewer screen, and welcome screen according to the state of app data. Now this app data will contain, of course, meeting ID and the mode. The mode will be called if the participant is a speaker or a viewer. Now by default the welcome screen will be started. So next we will start writing to code our welcome screen. As our welcome screen will create a new meeting, so we will have to write some code for API request to create a new meeting using for that will which will call the video SDK servers. So we will create a new file called api.js inside source directory. So, and here we will add some code for creating a new room. Now here it requires an auth token. Now auth token can be generated in two ways. First of all, using a temporary token which can be generated from dashboard. So you can visit our dashboard, and then from API section you can generate a temporary token. Next we can also generate auth token using API key and secret. So in production we recommend you to use the token generated by yourself from your server. So for now, for testing purpose, we will just use an temporary token which was generated from our dashboard. I copied the token from our user dashboard. Now I pasted it here. This token will be used for generating new room. Also this token will be used for joining the meeting. So we will keep this token as it is, and it will be also be exported. Next we will be creating a welcome screen so that the user or speaker can create a new meeting or viewer can join the new meeting. So I will create a new folder inside src directory called screens. Inside that I will create a new file called welcome screen container. .js. Now inside this will be a really basic screen. This will have its own state. It will have three functions: create new meeting, and join as host or join as viewer. Now this will have two parts. First part will be to directly create a new meeting without any permission, and after this click it will set the state and conditionally render the speaker screen. Next part will be for to join a meeting which was already created by the speaker. So here a user will enter the meeting ID and then will be join as host or join as viewer. Now welcome screen is completed. Next we will start writing code for speaker screen. Inside that screens directory I will create a new folder called speaker screen. Inside that I will create a file, because this speaker screen will be divided into three different parts, so I will combine it into the single folder. It's called speaker screen container.js. This will render meeting provider, media controls container, and participant grid container. So it will accept meeting ID and initialize the meeting with the video SDK meeting, and next it will render the media controls. So after this we will start coding for media controls container. So for that I will create a new file inside speaker screen called media controls container. .js. Now this will basically render few buttons to toggle the webcam, toggle microphone, and also to toggle the HLS stream, as he can to start the HLS stream and then the viewers will also consume the HLS stream when the speaker starts the HLS stream. So here I wrote some code for that. It will accept toggle mic, the meeting use meeting. This is the use meeting hook. This will return some utility functions for starting webcam and also for stopping the webcam, start toggling the microphone, starting HLS, stopping HLS. On also it will provide us some states. Now next I had defined new constants. Is HLS started, is HLS stopped, or is HLS playable. Now this everything will be created using HLS state. For simplicity I created those variables, and this will used for toggling the HLS stream. Now next I just rendered the meeting ID of that. The current HLS state, is HLS playable or not. Then conditionally rendered, the viewer will now be able to watch the stream, and 3 buttons for toggling webcam, microphone and HLS. So after that we have participant grid container. Now this component will be responsible to render each and every remote participants of the session. Let's say I am in the meeting and 2 or 3 other people are also in the same session. So I have to render those participants inside a grid. So this will be responsible for that. So for that I will create another file inside speaker screen folder called participant grid container, participants grid container. It's plural. Yeah. Grid container.js. So here it is. Basically it will get participant list from use meeting hook and generate a participant ID array from that participants, and that map through each and every participant and render a single participant container. Now this is just for mapping or iterating the single all the participants. Now the actual code for rendering the webcam stream and the microphone stream will be written in this file. So for that I will create another file called single participant container. So I will add some code for that. Now I will explain you each and everything what is going on here. Now it will just import some lab methods, hooks, and the component for rendering the webcam stream. It will accept the participant ID from prop and use another hook from our React package called use participant, and it will return some states and streams from as a value. If the microphone is on, microphone actual stream, is the participant local or not. Now this is useful for conditionally render if the local participant is there. Let's say I am in the meeting and I am the local participant for my browser. Another participant is there, so he will be a local participant for his browser. So if I don't want to listen my own microphone stream, so it will echo my voice. So to block that, we will conditionally render the microphone stream. If and only if the participant is remote, then only we will render the audio streams and some other stuff like display name and webcam stream. Next we had taken audio player ref. This will be useful for selecting the HTML element which is rendered here. As you can see, this is the ref is provided here. Next is web video stream. Now using the webcam stream and the boolean value, we will create a new media stream and then add a track inside the stream, and then use that media video stream inside the React player. So this React player will only render the webcam stream of all the participants. And next is this uh, this this effect is used for microphone stream and microphone stream for remote participant. Now here on, as I said, if the participant is not local, if the participant is remote, then only run this code. So it will again uh, create a media stream and add the track inside it, and then play the media stream accordingly. So this is what is happening inside a single participant container. So our speaker screen container is completed. Next we will start writing code for viewer screen container. So viewer screen container will be basically for viewer participants who will just watch HLS streams. So inside screen directory, I will create a new file called viewer screen container. Now this file will be responsible for playing the HLS stream, and also it will display the waiting message until the HLS is not started on, or we can say HLS is not playable. We will display a waiting message so that participant can wait. So um, here it is. So same as speaker screen container, we will pass meeting ID, and using meeting provider coming from the video SDK React package, we will render meeting provider. It will automatically join. Now here one thing we have to note is we have to provide more is equal to viewer. Now as a participant is called viewer, so inside video SDK we have to pass that mode as well, so that he will not consume any WebRTC streams. He will just consume the chat. Next we have also used a meeting consumer. um, it will pass a states HLS state. Until the HLS state is not playable, we will not render the HLS player. Until then we will render the waiting message, so waiting for host to start HLS stream. So coming back to the HLS player, um, here we have destructured HLS URLs and HLS state from use meeting. After that we have checked if the HLS is supported or not. We have used HLS.js library for playing the HLS string, and after that we will not conditionally, but we will render the HLS stream to this video. So I will save this file, and so our app is completed. We will start testing our application. So npm run start. So our application is running successfully. So I will test it and create a new meeting. So as you can see, our meeting ID is created. Now as you can see, the HLS is stopped, and as you can see, the webcam is started. Now if I start the HLS, so it will be available for viewers to play the HLS stream. So before that I will duplicate this tab and enter the meeting ID and join as a viewer. So as you can see, waiting for host to start the stream. So once I start the HLS stream, the HLS is in starting stage, so we will wait for that. So it is started. So until the HLS is not playable, we will not display the HLS stream. Okay, so HLS is now playable. Now viewers will able to watch the stream. So as you can see here, um, the HLS stream is started. The HLS is not playable, we will not display the HLS stream. Okay. So it will loop through it. I will pause this. Okay. So now we have successfully created a really basic application using React SDK. So what next? Now we can customize this whole application and add some more CSS into it and create a really beautiful website. Also we can add interaction using the pub/sub. Now you can, now both viewers and speakers, they both can use the pub/sub um, hook, and also can create an interaction in a unique way. Let's say if we want to build a poll, then the pub/sub will be used for that. Let's say if we want to start a Q&A session, then also pub/sub will be used for that. Also um, we can use the change mode API from video SDK. Change mode. So what it does is, let's say if there is a thousands viewers and there is only 10 speaker in the session. Okay, so let's say from those 1,000 viewers we want to pick any one user and make them as a speaker. So currently in our application that is not possible, but you can use this change mode API to change the mode of any particular participant from viewer to host, or a host to the viewer. So that can be also implemented. So there are endless possibilities with video SDK's React library. So thank you so much for watching this video. I hope you will create your own application for interactive live streaming, and thank you so much. Bye.